Today I'm going to start with the sixth problem of exercise 8.4. So as you can see that it is asked to prove LHS is equal to RHS. That LHS is given as square root of 1 plus sine A divided by 1 minus sine A. So the first question arises is how to bring this out of square root, because in the right hand side there is no square root. So it is obvious that this should be coming out of a square root. So we should remove this square root. How to remove it? So if we know that for example, if there is a term x square root of x, so we know that this can be written as x, but there is no such if there is a root x, you can only write it as x power 1 by 2. So there is no power 1 by 2 in the right hand side. So we have to make sure that the square term comes inside the root so that we neutralize the root. But how to get the square term? So if you think for a few moments wisely and try to analyze how to get the square term in the numerator and as well as denominator. So what happens if I multiply? Consider if I want to multiply by 1 minus sine A in numerator and denominator inside the square root. So what will happen? So denominator will become 1 minus sine square A and the numerator will become as 1 minus sine whole square A. So what will happen? Just this is not required, but I am just telling that what will happen. So this term here, if you know, this term here will become, this is a square root term, so inside the square root, so this term will become so 1 minus sine square A is nothing but cos square A. So square root of cos square A is cos A by 1 minus sine A. So this is literally I can say that there is a little bit difficulty here because we don't want any term in the denominator as well. Denominator we need only a single term, that is if you check the RHS, the denominator term should be cos A, because sec A is 1 by cos A and tan A is sine by cos, so denominator we need cos A. But here something different has happened. So this is also can be done. So even if you simplify once you try simplifying, if I divide a cos on numerator and denominator, then it will be sec of A minus tan of A. So this is the result we are getting. So now again if I want the numerator term, I multiply this by secant of A plus tan A by, on the numerator and denominator, if I multiply by secant of A plus tan A, then it will become secant square of A minus tan square of A. So using A plus B into A minus B. So this we know that this term is 1. So this is a method to do this question, but this is not required. I am going to completely reject this method because there are so many steps involved and also there are so many chances of making a mistake. So I am going to state one more easy way of doing it. What if I try to get the numerator in terms of cos? So let us try multiplying the new denominator and numerator by 1 plus sine A. So what will happen? Just check it up. So 1 plus sine A into 1 plus sine A by 1 minus sine A to 1 plus sine A. So now what will happen is that we know that from the formula A square minus b square is equal to a plus b into a minus b. So using this result, I can write as denominator can be written as 1 minus sine square a, and numerator is 1 plus sine a whole square, 1 plus sine a whole square, and the denominator is 1 minus sine square a square root over it. So now this is LHS. I can write LHS. So which is equivalent to now because since we are considering we are generally considering only from angles from 0 to 90 degree. So theta, not theta a. I've already said that I am using angles theta and a, both are exchangeable. It's just a notation. So 1 plus sine a. So now I am only considering the positive angles here. So I am neglecting the minus sign, because if you take actually the square root of x square will be plus or minus x, but I am neglecting the minus term. So because we are considering only between 0 and 90 degree, angle a is between 0 and 90 degree. So what will happen is that now 1 plus sine a is a numerator, so we remove the square root in the numerator, but the denominator again, if you check that, if I use the formula cos square a plus identity sine square a is equal to 1, this is a universal identity, this is angle, this is valid for all angles, valid for all a. So it doesn't matter if this a is even greater than 90 degree. But this one, this identity which I said before, this is valid only between 0 to 90 degree. Then angle A is between 0 and 90. So this is a reason why we try to, I always say why use it in terms of cos and sine, is because this identity will be always valid with respect to angle, any angle. So now 1 plus sine A, because of course in class 10 we are only considering from 0 to 90 degree, but later on you will be going many angles in class 11 and 12. So that time it will be useful. So 1 plus sine A, and denominator, if I write this in terms of cos square A, if I rearrange this identity, then cos square A is 1 minus sine square A. So cos A is nothing but, so cos square A. I can replace 1 minus sine square A by cos square A. The square root will remain cos square A. Again I am considering between 0 and 90 degrees, so I will only take the positive root of the cos square A, so it will be equal to cos A. So now in the denominator I have managed to get the cos. So now let us write like this. I will split the numerator in the form, if I divide directly using the cos A, I can write the expression as 1 by cos A plus sin A by cos A, which is equivalent to 1 by cos A is secant of A and sin A by cos A is tan A. So these are the two methods to solve this problem, and you can think which one is easier, and because one is based on this identity, one is based on this one, and one is based on using again oversimplification here. So this one I reject this, I consider this as unconventional and not required, but it is always better to know what are the different ways to solve a particular problem, even though it might be lengthier. Sometimes it might be useful because this may be only method to solve the problem. In that case, it might be useful. So I'm going to start the next question. So what is the next question? Question number 7 in the fifth part. Fifth question, exercise 8.4. sine theta minus 2 sine cube theta divided by 2 cos cube theta minus cos theta. So equivalent to, this is equivalent to tan. So we have to prove this. So now this problem is simpler because already it is in terms of sine and cos. So only a simple manipulation we need to do to get to the result. If I take right hand side, now I can, now you would have been observed that I can take sine common. I can take sine theta common from here. It is nothing but 1. So I will get 1 minus 2 sine square theta by, if I take cos theta common in the denominator, then 2 cos square theta minus 1. So now if you observe sine theta by cos theta, now if you observe that this expression, so this expression is already tan theta. This is already tan theta, right? So this is tan theta. So we got the right hand side result. But here these two expressions are this expression. But if RHS, LHS will be equal to RHS only when this is equal to 1. But how? Because we know that 1 minus sine square, 1 minus sine square theta is cos square. But 1 minus 2 sine square theta, what is it? So how to proceed further? So now what I'm going to do is that now we want to cancel, to prove that this is equal to 1. We have to prove it. So we have to get the numerator and denominator in terms of either sine or cos. So I am going to substitute in the numerator using the identity sine square, and using the identity sine square theta plus cos square theta is equal to 1. I can write sine square as 1 minus cos square theta, 1 minus cos square theta. If I write like this, the numerator, so what will happen? Sine, so let it, I write this as tan theta, I'll keep it like this aside, and 1 minus 2 into, again sine square theta, instead of sine square theta, 1 minus cos square theta. So rather you can even do one thing, that even in the denominator you can substitute, because this minus sign, there is a chance that many people may commit an error, because so better to write cos square theta is equal to 1 minus sine square, and both are same, but because there is a minus sign, there is a more probability that someone may commit a mistake. So I will keep the numerator as same and try to substitute the denominator. I will make it terms of cos square. So 1 minus, so both are correct, but both are same, but the minus sign, we don't want to add the extra complexity here. So 2 into cos square, I can write 1 minus sine square theta minus 1. So I will put like this now, 1 minus 2 sine square theta divided by 2 into 1 is 2, minus 2 minus 2 sine square theta minus 1. So 2 minus 1, the like terms, 2 minus 1 is equal to 1. So now the denominator, so it will be 1, 2 minus 1 is 1, so 1 minus 2 sine square theta. So this is equal to 1. So now this is what you have proved. So this is 1, so remaining will be tan theta. So tan theta, so we have proved that LHS is equal to RHS. So if we, what if I put in terms of sign? Let us try here what will happen. So already we got the result, but let's see where there is a chances of doing an errors. 1 minus 2 into 1 minus cos square. So instead of sine square theta, I am substituting 1 minus cos square theta. So denominator is 2 cos square theta minus 1. So which is equivalent to 1 minus 2. So here minus into plus will be minus, so minus 2, then minus 2 into minus cos square theta is plus 2 cos square theta. So this both are similar, but there are cases where we commit a mistake. If there is a negative sign, we try to avoid it. So then 1 minus 2, again it's a minus 1. So minus 1 plus 2 cos square theta. So now I can, instead of writing this minus 1 at the beginning, I will write at the end. After cos theta, I will write it. So now if I write that, so after cos theta, if I write it, so it will be minus 1 plus 2 cos theta minus 1, and then cos square theta minus 1. So these both are same, so again the result will not change, is equal to 1. But my motive is that I want to show that there are so many methods to solve a particular problem. So I want to show why something is better than other method, or why some methods are better and why some methods, there are chances of making an error while solving the problem increases. So even in the previous problem we solved that, saw that there may be two ways to solve a same kind of problem, but why this one is a better approach. So in this case, the difference was only a negative sign, but the previous problem, the method, the first method which I shown, has so much complexity. So in this way, we can solve this problem, and in the next video, I'll continue with the next set of problems.